Hello, everybody. So we are talking about functions today, starting off with a very important topic. A function is a relationship between two things, between the x's and the y's. And we call the x's the domain and the y's the range. But it's a special relationship and one where everything from the domain, every number from the domain goes to exactly one number in the range or one element. It's kind of a convoluted definition. It's easier to understand it in the negative. If any domain number goes to two or more different range numbers, then it's not a function. There's also all sorts of ways you can make functions complex, but for us, we're almost always going to deal with x and y with an ordered pair, an input and an output, a domain and a range. So from this point forward, when you see x, y, an ordered pair, you could think domain, range. So here are some examples of functions and non-functions. This is a function. Remember, every domain element goes to one range element. If I ever have a domain that goes to two different ranges, I'm in trouble. It's not a function. 2 is the domain. If you plug in 2 into x, you get 3 times 2, which is 6, minus 10, which is negative 4. So 2, the domain, goes to negative 4, the range element. And 0 is in the domain. If you plug in 0 for x, you get 3 times 0, which is 0. Minus 10, you get negative 10. So there's another relationship between one domain and one range. Same thing with 6. 3 times 6 is 18. Minus 10, you get 8. 6, 8. Domain, range. Looking at examples like this, you would think everything's a function. Here's another example of a popular function, the square root of x minus 5. So this equation relates x to y, relates the domain to the range in such a way that no matter what x value you put in here, you are going to get one y value only. For example, 9. If you plug in 9 for x, 9 minus 5 is 4. The square root of 4 is 2. You're always going to get 2 if you plug in 9. So that makes it a function. If you plug in 5 into x, 5 minus 5 is 0. The square root of 0 is 0. If you plug in 8, what do you get when you plug in 8 for x? 8 minus 5 is 3. You get the square root of 3. So the square root of 3 belongs in the range. 8 belongs in the domain. 2. If you plug in 2 into x, you get 2 minus 5, which is negative 3. Now what's the square root of negative 3? That is an imaginary number. And most often when we talk about domain and range, we exclude imaginary numbers for a lot of our classes, this class especially. So imaginary numbers are out the window. We're not going to talk about them. We're not going to think about them. So if 2, a domain element, leads me to an imaginary number, then what's my conclusion? 2 is undefined. The function is undefined when x is 2. Or in other words, 2 is really not in the domain. This is not a function. This looks like 3x minus 10, except there's another symbol, 3x plus or minus 10. So if you plug in 2 into x, what are you going to get? Over here, if I plug in 2 into x, I'm always going to get negative 4 because this is a function. Every time I plug in 2, I'm going to get negative 4. What happens here? If I plug in 2, I get 6 plus or minus 10. So that's 6 plus 10, giving me 16, and 6 minus 10, giving me negative 4. So this is a classic example of something that's not a function. 2, a domain element, is producing 16 and negative 4. It's producing 2 different range elements. So that's not a function. Y is less than x plus 6. Well, if you plug in 5 into x, what is the result? If you plug in 5 into x, you end up getting, what you're really saying is y is less than 11. So here it was very, very determined. If you plug in 6 for x, you're going to get 8. You just follow the rules. You multiply, you subtract, you get 8. Here you have more freedom. If x is 5, the result is y is less than 11. So any y value that's less than 11. There are lots of y values that are less than 11. All of these ordered pairs are on this relationship. It's not a function because 5 could go to 10, 5 could go to 9, 5 could go to 8, 5 could go to negative 33. In fact, I should say 5 does go to those. It goes to many, many numbers. In fact, 5 goes to every number that's less than 11. So one domain element 5 goes to many, many different range values. So y is less than x plus 6, not a function. Is this a function? You have 4 little ordered pairs. The domain is the input, so you've got 1 as a domain, 3 is the domain element, negative 4 and 0. And then you've only got 2 range elements, 5 and 3. Is this a function, yes or no? Well, if you said no, I'm sorry to say you're wrong. It is a function. It absolutely is a function. If you say no, it's not a function, why not? If you say it's not a function, you have to identify one domain element that goes to at least 2 different range elements. And that doesn't happen here. 1 goes to 5. Does 1 go anywhere else? No. 3 goes to 5. Does 3 go anywhere else? No. Negative 4 goes to 5. Does negative 4 go anywhere else? No. And 0 goes to 3. 0 doesn't go anywhere else. With these 4 ordered pairs, the domain elements, the x's, only go to 1y. Now I know that a lot of things are going to 5, but that's okay. 3 goes to 5, 3 doesn't go anywhere else. It's the x going to the y. It has to go to 1y only. Here is a relationship with 5 ordered pairs. The first 4 are listed. Out of these blue ordered pairs, which one could I add to here so that the relationship is not a function? First of all, are these 4 even a function right now? 8 goes to 9. Does 8 go anywhere else? I have another 8 here, but notice this 8 is going to 9. So this 8, 9 is just a repeat of this one. So it's still a function. 8 always goes to 9. 5 goes to negative 2. It's not going anywhere else. 3 gets mapped to 0. Well, I could put in 3, 0 again. That's just another repeat. 3 goes to 0. 3 doesn't go anywhere else. 3 doesn't go to 1 or to 2. 3 goes to 0. So this would still be a function. So I'll put it over here. 4 goes to negative 2. Would this make it, would just keep it a function, or does this make it not a function? This would keep it a function. 4 goes to negative 2, and it's only not a function when a domain goes to 2 different ranges. And that's not the case here. Out of these 5 ordered pairs, 4 goes to negative 2, and I don't see 4 going anywhere else. This is a problem. 5 goes to 3. Hold on a second. 5 was already mapped to negative 2. How can 5 go to 3? So this right here would not be a function. So that's going to go in the make it not a function category. 8, 2. Hold on a second. 8 went to 9. So 8 can't also go to 2. It would be like you have a phone and you dial the phone number to reach your friend. That's a function. Every time you dial that phone number to reach your friend, your phone is going to connect to your friend's phone every single time. What if you had a phone that if you dialed the same number, you would get all sorts of different friends? That wouldn't be a function. That wouldn't be a good phone. You need to depend on your phone. If you dial this number, you're going to get this friend. That's what a function is. But here with this 8, 8 is going to reach 9. 8 can't reach 2 at the same time. That's not a good thing. It's not a function. 3, 1, no good. 3 already goes to 0. 3 can't go to 1, not a function. 5, 1, no good. 5 already goes to negative 2. 5 can't go to 1. It's already going to negative 2. Can't go to 2 different places. 1, 10, that's fine. 1 goes to 10. I don't have any evidence here that 1 goes anywhere else. So that'll do it.